Mark P. Otten back with you. All right, welcome to your two-way ANOVA in R video. This one is the two-way ANOVA if you have one independent variable that's independent samples and the other independent variable that's dependent samples, which is known as a mixed design. You have one of each. So as I have done in another ANOVA in R video or two, I have switched the format a little bit of the data before loading the data into R. So I've done that in SPSS. There's ways that you can enter data directly into R that I am not showing you. I'm just more comfortable using SPSS for this part. So the data on the left matches the data that I ran you through in the SPSS tutorial for a mixed ANOVA. That's participant. Now it's I don't know, my labeling in that video was a little bit weird. I just decided to keep it consistent. So I say participant there. This is actually a gender column. It's 1 for female, 2 for male. So I just called it participant. I decided to keep it consistent. Also, when I tried to switch the label from participant to gender in R, or for R to run the correct analysis, it wouldn't do it. It was weird. I don't know why. Anyway, let's keep it as participant. It was a sign that I should keep the labeling consistent with my SPSS video. So on the left there you see 6 participants, 3 female, 3 male, and 2 time points of jumping jacks. So the first participant there did 25 jumping jacks at time 1 and 27 at time 2. What an athlete. And that's a female participant. In this case, the between subjects or independent samples IV is gender, right? 3 females, 3 males. There's no repetition in terms of measurement of gender. The within subjects or dependent samples independent variable is jumping jacks, or I guess you could call it time. Yeah, let's call it time with 2 levels, time 1, time 2. Jumping jacks then is your dependent variable. So if you're looking again at participant 1, they did 25 jumping jacks at time 1. That's dependent, jumping jacks dependent on time. Perhaps the hypothesis could be that people got tired. Maybe they did fewer jumping jacks at time 2. Certainly true for participant 2, who did 29 at time 1 and then quit. Didn't do any at time 2. All right, so that's the setup. Run the mixed samples ANOVA in SPSS. You get your results. We did that in a different video. So for R, we converted it over and created one additional column. So the additional column here is just a label for which participant it is. So we've got 1 through 6, and then we've got repeating 1 through 6. And we call that ID because the gender variable I labeled awkwardly, like I said earlier, as participant. So we've got 6 participants here, and then you've got the gender labels here as female and male, 1 for female, 2 for male, and then that repeats as well. And the reason it's repeating is because we've loaded all dependent variable values into one column. So jumping jacks all go into the jumps column instead of 2 separate columns. And then we've got time here labeled as jumps 1 and jumps 2. And then again, for R, it was easier for me to type this in as jumps 1 and jumps 2 as opposed to like 1 and 2 for some reason. So I kept it that way. So if you're entering this into SPSS, I typed in words, which automatically converted this variable into a string variable instead of a numeric variable for SPSS, but that's fine. R reads it in well. In fact, it read it in better than a numeric value for some reason for the time variable. So same data, 2 different formats. If you get stuck at this step, translating your SPSS results to your R results, let me know. We will give up together. No, we will figure it out together. All right, so let me switch over to R and show you what this looks like. So first of all, I imported the data, the edited data, the reformatted data into R here. And so you see the format matches the second version of SPSS data that I just created. So you import that in first. Then before you type in your code or before you copy paste this stuff, you're going to need to, and this might be selected automatically for you, I don't know, but you're going to need to go down to the bottom right here and select the rstatics package. Just to run it the way I did here, you're going to need to do that. So that's the first step, and then you can tackle the code here. Now, first of all, if you're wondering, like, because this code looks a little bit different, it's a little bit different setup than it was for my other two-way ANOVA, like the one where both IVs were dependent samples. The two-way dependent samples ANOVA code looks pretty different than the two-way mixed samples ANOVA code that I'm showing you in these videos. Why is it so different? Well, it doesn't have to be. Like, we could take the two-way ANOVA independent samples, that setup, that kind of syntax, I don't know what to call it, that particular style of syntax, let's say, and then use it here, and we could, and it would work. But I'm just trying to get you the quickest I can from point A to point B and not sweat the code too much. So for the mixed samples ANOVA, I switched it over to this particular style, and I'm pulling from different websites. I also have I want to shout out Dylan Aguirre, CSUN grad student, who worked with me on this particular code, because I was trying to get the other one to work, and it wasn't agreeing with me. So then I was like, Dylan, what should I do? And then he recommended switching over to this code. So the first line of this code reads in the data, right? So here's my variable name, ANOVA 2IV3 for R. That's what I called it. Call it whatever you want, as long as you keep it consistent there wherever it appears in the code. And then the first line here, what it's doing is declaring ID and time as factors, as, well, in this case, time is it's time 1, time 2, right? That's our dependent samples IV. So whatever your dependent samples IV is, that should go into this first line. So convert as factor is declaring time, in this case, as a dependent samples IV. The ID is also in there. That's your label for your participants. So like that should be in there too. So whatever you're labeling your participants as goes in here. That's ID, and then your dependent samples IV goes in here as time. So that's why it was key to convert the data format first, because now we're able to code it properly here. Okay, so we've got this first line then. You're leaving out your dependent variable, and you're leaving out your between subjects or independent samples IV, which in this case is gender, or as we've labeled it, participant. And so then we go down to the next line and we see these coded separately. So res.AOV, that's your ANOVA setup, a left arrow, ANOVA _test. This is all just setting up an ANOVA for you. You declare your data here with your file name, should be consistent with the first line. Dependent variable is jumps. So if we flash back to the data here real quick, jumps, like I said earlier, it's all coded into one column. So you're just declaring that as your dependent variable, and that, again, it's useful to have it all in one column. WID equals ID. This is WID equals whatever you called your participants. So in this case, it was ID. Then you've got your between and within over here. So between is participant. That is your independent samples IV. It's actually gender, but I'm calling it participant to stay consistent with the results from SPSS that I have in my video there. And then within is your dependent samples IV, which needed to go in the first line as well, like I said. So it's time in the first line, time here. And then detailed equals true just gives you your complete detailed output. And then you're good to go. You've got get ANOVA table. Let's run it, see what happens. Okay, so I'm gonna make this a little bigger. All right, so I did run this one other time, so that's why you're seeing the output there. But this is the key section here. I'll highlight it for you. Yeah, you're seeing a little bit of output twice, but it's because I just ran it before. Don't worry, it's just this section here that I've highlighted. Okay, so you've got your three key results here. You're looking for main effect of participant, in this case, which is actually main effect of gender. That's line 1. So line 1 here, you even got a star. R has given you a star, an asterisk, to indicate that 0.046, your p-value, is significant in that it's less than 0.05. The F value 8.197 and so on for that line. Time main effect, not significant in this case, 0.409 p-value, 0.85 F, very small. And then your interaction participant, time, p-value 0.44, F 0.73, also very small, so not significant, p-value greater than 0.05. That's it. That's all I'm going to tell you for our mixed samples ANOVA in R. Keep me posted if you get an error message. Don't worry, I did too. We'll figure it out together.